All right, so on this one, this is finishing up the review for which test? Polynomial divisions, rational functions. So again, like I said, finish it up. This is my 5th hour. Hey. Oh. Okay, that was so weak, you guys. Come on now. You can do better. All right, so it says, let F be a polynomial. Huh?
You're going to say class. And then
Okay, let's try it again. Class.
Yes.
Okay, all right. Is that what I was supposed to do?
Yeah.
Okay, good. All right. There. So even better. Thank you. It says a function of x where f of x is equal to all of this. If x minus 1 is a factor of f, write an equation for f as a product of linear factors. Linear factors. This goes along with what we did the first for 215 and for what we did for Roman numeral 15. Sorry. So Roman numeral 15 also. Sorry. I know, I almost died. So I that's what we did Friday of last week. So Friday of last week, we did some factoring to go along with this. So now I'm going to do this, and I'm going to do this using the box method. So on this right here, I actually did long division. So I'm doing both methods on this review so you can actually see both methods. So for this right here, polynomial, so it's going to be x minus 1. So in my box, I have x, I have negative 1. So when I do this right here, I start off with my first term, which is x cubed. So what that means is I have to find out what my something is. So something times x is x cubed. X squared? Did I lose someone on that one? I heard of what? No? Maybe? No? Because that's what we're doing here on this one. This is the something. So something times this. What's up? I got negative 1 from this one over here. So that's where I got that. Okay? All right. Oh, you want to come up closer? I got spots up closer if you want it. You good? Okay. Now, I have my something. Now I have to multiply down. So it's x squared times negative 1, negative x squared. There we go. Do what?
Is it fine if we put negative 1x squared?
Yeah, it's negative 1x squared. It's fine. So now over here on this next one. So now I have x squared. So now I look at my x squared. My x squareds have to add up to negative 2x squared. So I have a negative 1x squared here, and something has to add up to negative 2. Not 2. No, not negative 2. Look, I have a negative 1 here, right? So it's going to be another negative, right? Another negative x. Like this. Like this. So, this is a negative 1x squared, and this is also a negative 1x squared. When I combine the two negative 1x squareds, that's going to give me my negative 2x squared. So, that's where I was going at right there. So now I have to do those, and I'm going to start changing colors on this. So, this one and this one has to equal this one right there. Oh, got a little bit too big there. There we go. Huh? Yeah, you're adding those together. Go ahead. So we are adding these together now for that. All right, so let's see. Let's go ahead. I'm going to change up my color again. I like purple. Purple's a good one. All right, so again, something times x is negative 2x squared. Negative x. Negative x. Now, if you notice, if you look at my degrees should be going down. I have an x squared, then an x1 right here, right? And then my next one should have no x. So if I'm paying attention, that works out very good. So right here, it's going to give me negative x squared. So now I multiply down. So negative x times negative 1 is positive 1x. Very good. Yeah. So now I'm looking at this one right here. It's negative 19x. But I have positive 1 here. So together, this one and something right here has to add up to negative 19. Negative 20. So it's negative 20x because the variables stay the same. Variables stay the same here. Okay? All right, now, again, my something. The something times x is negative 20x. Negative 20. Okay, and then multiply down. Positive 20. Did I get it right?
Yeah.
Yes, I did. I did get it right. So this one comes out to be there. So now it works out. It is a factor. It is a factor, so that does work out. So now the next thing I do is, I know that this is a factor. So my factor is going to consist of x minus 1. Now, and it's also going to be times this. So now I'm going to break this up now. So I'm going to just do this piece. So that x squared minus 1x minus 20. So I've done this a couple times, and you could do the ABC method, which I showed again on Friday, or you could do the method that we did back on the 215 lesson. So I'm looking at this. Now, two things that are going to give me x squared. What's going to give me x squared? X and x. So my first term is x and x. Now, the next thing over here is negative 20. So, two things multiplied to be negative 20. Desiree, can you please have a seat and wait till I'm done? So, two things multiplied to be negative 20, but add together to be negative 1. So, if I'm listing my possibilities, what is going to give me negative 20? Negative, let's say 2 and 10, right? Negative 2 plus 10. Is that going to give me my negative 1? No, it's not. Is there any other factors? 1 and 20? Negative 1 and 20. Is that going to give me negative 1? No. 5 and what? 5 and 12?
5 and 4.
5 and 4. Let's look at 5 and 4. 5 and negative 5 and positive 4, right?
Yeah.
So those two multiply to be negative 20 right here, right? So they multiply to be negative 20, but when I add them together, does it give me my negative 1?
No.
Yes, it does. So guess what? These are my two that go right over here. So minus 5 and plus 4. So I could do the full thing right here. So
You would just finish right there, right?
yeah, I could be done because that's my third one. So if I were to distribute this out, if I were to distribute it out, I get x squared and then plus 4x minus 5x and minus 20. So when I add them together again, x squared minus x minus 20. So I distributed and I come back to get my same thing, right? And then if I were to try and get that very first thing right there, I would also multiply by my x minus 1. So my three answers I'm going to have here is my linear factors, which is going to be here, right? X minus 5, x plus 4, and x minus 1. That is linear factors. So by linear, it means it's x to the first degree right there. So a linear is just going to be like this. All right, questions? You want me to go over it a little bit more or clarify anything? So you'll see some people copying down, so hopefully. Alright, let's take a look at the next one then. Oh, yes, no? Can I go to the next one?
No.
No? Okay. We ready?
Yeah.
Alright, so here's number 6. It says a boat is going to travel 200 miles at a planned speed of 90 miles per hour. The current of the body of water that the boat is traversing, so it means it's going through, will have an average current of c miles per hour. Okay, c miles per hour for the entire time. Meaning the traveling directly against the wind time t in hours of the voyage is a function of speed of the current c in miles per hour and can be modeled by this. So that's important. So now, it's a long word problem that has a whole bunch of stuff that you really don't need, right? So, we have this right here. Okay, so here's a graph of it. So for those people out in YouTube land, I'm going to trace that over so we could actually see it a little bit better. Because I know someone's trying to watch this on their cell phone, and their cell phone's got a little bitty screen. Okay, so there it is right there. Now, what does t of 50 mean in this situation? Okay, time, right? But what did the 50 replace? Speed of the current. So speed of the current is c, right? So 50 replaced the speed of the current. So let's go through and figure it out then. So it means that at this time, so speed of the current is 50 miles per hour. Now, let's go ahead and look at speed of the current. So at 50, where's 50? Where am I going to look at for the 50? All right, is it going up or is it going along the bottom?
Along the bottom.
Along the bottom, right, Jonathan? Yeah. Okay, so along the bottom, we try and find 50 now. Let's go ahead and find 50. When I blew this up, I don't think it actually came out very well.
4.5.
Right here? Is this right? Right about there?
Yep.
By 10. So.
Okay, so it is by tens. Dang, alright. Man, you guys turn your ringers off, dang it. Alright, so right about there, that looks like, what does it look like on your guys'? Because mine is kind of blurry.
4.5.
4.5?
Yeah.
Okay, so now what is the time going to mean?
4 hours and 30 minutes.
Yeah, 4.5 hours. So it is 4.5 hours. So that's what we're getting that from. So right here, and it's looking for the time. So if the speed, you guys are looking right here,
Yes.
if the speed is 50 miles per hour, it's going to take me 4.5 hours to travel that distance.
Awesome.
Yeah.
So 200 miles.
Just to let you know, on the water, you know, when you are traveling on the water, it's painful going really fast.
Oh, I thought it was
Yeah,
like
water,
it was
yeah,
water.
yeah. Just so you
It
know.
was like driving.
Oh, yeah, not driving, but yes, just, yeah. Anyway.
No, also, you don't have
Okay, this next one, it says, at what value c does a graph have a vertical asymptote? Now, look in your notes right now. In your notes right now. 218. 218.
to- Yeah, I just did that yesterday.
28. I'm trying to teach here. It's not all about you.
I have a question, but alright.
Okay. 218, please. 218. Everyone, 218.
0.
Yeah. So remember when I said, hey, you know, if you have your notes out, that'd be beneficial, it'd be helpful. So 218, find 218, find the notes for 218. So I know that there is people that did take the notes on this.
My name is in the system.
So for 218, go find me where it says vertical asymptote. I had you write it down.
Wait, patch out.
Yes. What is this? Really? In the middle? Come on.
Please.
Vertical
You're already
asymptote bottom equals 0.
Thank you. Thank you. I appreciate it. Thank you. I appreciate it. I do. Like, I greatly appreciate it. Okay? You're my homie. Okay. So,
Ooh, get out of my face. He's trying to help you.
I don't want his help. No, because when I had a question, he didn't want to answer it, right?
Wait, the vertical asymptote?
Yes, the vertical asymptote.
is when the bottom is equal to 0, right?
Yes, sir.
So what is the bottom of the function?
0.
No, what's the bottom up here?
Oh, 90 minus
90 minus c. So I go 90 minus c equals
0.
0.
Wait, so I don't think I got that answer.
Huh? Oh, yeah, I had you guys write it right there, yeah. Yeah.
That's it?
Yeah.
Oh, I just
So that's a vertical asymptote right there. So now, I'm going to know where is my vertical asymptote going to be. So what do I do to solve for it? Do what? How about add c? Because this is minus c, isn't it? And I want to get c by itself, but since it's already negative, I want it positive. So I'm going to add c to both sides. So 90 is equal to c. This is my vertical asymptote.
oh, you can see how you're bad.
So that is my vertical asymptote at 90. So let's take a look at this. Why is there a vertical asymptote there? We got to go to the word problem for this one. You got to read through it.
Because these plants will go how many miles per hour?
Yes, he's going 90 miles per hour, right? And what does C represent?
Speed of the current.
Speed of the current. So if I'm going 90 miles an hour and my current is also 90 miles an hour, I'm not going to go anywhere, am I?
No.
That's important to understand. So right here, because I'm going 90 miles an hour, and the speed would be 90, which is right about here, I think.
Yes.
Yeah, so it's right there. So if I'm going the same speed as the current, then I'm never going to go anywhere. Like running on a treadmill. Find that annoying.
What?
Running on a treadmill. It's pointless.
I mean, you're
Just
burning
go out.
you're burning calories.
I know, but you know, go outside and look at something. You know, go run around the neighborhood. Maybe not in your neighborhood.
But
Yeah.
that's like
Yeah.
you don't even know what neighborhood I live in.
Okay. In the ghetto. All right.
No, I live right down Central.
Yeah, on Central. Yeah. Yeah. That's it. Seriously, I was watching a guy when I was at a stop sign. He was at the light rail. He was bathing himself in the drinking fountain.
That's the light.
Don't ever drink from the light rail drinking fountain.
Never.
Never. I'm telling you, don't ever. That one right there, the dude was washing himself in there. He was like, you know, savacos and like just, ugh.
You know this is all recorded, right?
I know it is, right? Okay, so now we talk about how I get off on tangents all the time. So, ain't that right, Jake Quellen?
Yeah.
Okay. All right. Now,
Well,
so right here, did we actually show this right here? Say yes.
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 So I have a vertical asymptote at when 90 is equal to c because it is the same speed as the water. It's the same speed as the water. So you're going to write that out for this. So we got the math for the vertical asymptote is my denominator equal to 0. So I got the math set up here for my vertical asymptote, and you could explain why. Now, questions. Any questions? I think I hit most questions right here. I think, is that the last one? Yeah, that one's the last.
Yay.
All right. So don't forget, like, share, and subscribe. Hit that notification button. Okay.
Don't.
After we get, I don't know, what else do they offer?
200 followers to doing that gift card giveaway.
Yeah, gift card giveaway.
You'll get a good grade if you subscribe.
Oh, yeah.
You need to
Everybody's
sponsor.
subscribed,
You need to put some ads in.
Actually, I had Burger King the first year I did this.
though. Burger King?
Yeah, so seriously, I know, because they got like free Whoppers. Yeah, I was able to actually give those out because I knew a manager over at Burger King and he gave me a bunch of those. So at like every video, I like pulled someone out from there and
You should ask your students if they work at like a